Hello and welcome back. In this video we will continue looking at Chapter 5. However, Section 2 will be about linear equations with three variables. So our three variables will be x, y, and z. And a linear equation is one where each term is going to be a linear term, meaning that we only have one variable in it, and it's raised to the first power, as in x to the first power is just x. We have a times x, we have a b times y, a c times z, and a constant term on the other side. So this is what a linear equation looks like in three variables. If you were to get rid of the z term, we would just get a linear equation in two variables back. We can also look at systems of equations with three variables as well. So for instance, here is a system of equation with three variables. Note that each equation we've written as ax plus by plus cz is equal to some constant. And what we want to do is we want to check if this is a solution. And just like for equations, for systems with two equations and two variables, a solution is just going to be an ordered, in this case triple, because we have three variables, that if we plug them in, they satisfy the equation. And the order of the variables is always going to be x, y, and then z. So let's plug this into the first equation here. So if we plug in -1 for x, -4 for y, and 5 in for z, we'll get, so that's just -1. -2 times -4 is going to be 8, and 3 times 5 is 15. So -1 and 8 is going to be 7, plus 15 is 22. It satisfies the first equation. How about the second equation? So let's plug in a -1 in for x. We'll plug a -4 in for y, and we'll plug a 5 in for z. We'll get 2 times -1 is -2. -3 times -4 is going to be +12, and -5. So -2 and 12 will cancel out, and we'll get 10. Minus another 5 is 5, and everything works out. Lastly, we have to check the third equation. So let's plug a -1 in for x, a -4 in for y, and a 5 in for z. So we have 3 times -1 is -3. We have just a -4 by itself. We've got 5 times 5, we'll get a -25 with a negative sign there. So -3 and -4 will be -7, plus another -25 will be -32, which matches. So from our original system of three equations and three unknowns, we plugged in our proposed solution, and we saw that in each case it is in fact a solution of each one of those equations. So how do you come up with a solution to a system of three equations with three unknowns? Well, it's essentially exactly the same as with a system of two equations with two unknowns. The first step is to eliminate one of the variables, and we eliminate it using substitution or addition, just like we would with two equations and two unknowns. And I'll go through what this actually means in an example. But essentially, by eliminating one of the variables and eliminating one of the equations, we're left with only two equations with two unknowns. Well, we know how to solve those, so we do. We just solve for the two variables that are left over. And once we know two of the variables, we can plug it back in to find the third. So let's go through an example. This will be a lot easier to see with an example. So we have the following system of equations. X plus 4y minus z is equal to -8, 3x plus 2y plus z is equal to 16, and 2x minus 3y plus 2z is equal to 26. So here we can see that we have three equations with three unknowns, but when we look at the top two equations, we can eliminate that z really easily. if we were to add the top two equations together, we have a negative z and a positive z, which would mean that these guys will cancel. So let's take the top two equations. We'll write them over here. Negative 8, and we've got 3x plus 2y plus z is equal to 16. So when we add these two equations together, x and 3x will add up to 4x, 4y and 2y will add up to 6y, and negative z and z will cancel out. They'll add up to 0, which is why I chose that, and negative 8 and 16 will add up to 8. So here we have an equation with two variables in it, not three. But in order to solve a system of equations, we'll need two equations with two variables in it to be able to figure out what both x and y are. So we use the first two equations to get this one. So this is equation number 1 and equation number 2. Now I need to choose a different pair of equations. And I'm going to choose equation 1 and equation 3 here. There are more choices here, but when I write these down, hopefully we'll see why I chose these two. 2x minus 3y plus 2z is equal to 26. When we write this down, here I've eliminated z, so I want to eliminate z again. And when I look at equation number 1 and equation number 3, I have a negative z and a plus 2z. So these don't quite cancel, but if I multiply this top equation by 2, they will. Once I multiply this by 2, I'll have a negative 2z and a positive 2z. Then I'll be able to add these together to get them to cancel. So the top equation becomes 2x plus 8y minus 2z is equal to negative 16. We will have 2x minus 3y plus 2z is equal to 26 on the bottom. And when I add these guys together, I get 4x plus 5y. Negative 2z and 2z cancel, so there's nothing left. And negative 16 and 26 will add up to 10. So now I have two equations with two unknowns. I got the first equation by combining the first two equations in our original one. And I have my second equation in two variables by combining our first and third equations with three variables. So now I have two equations and two unknowns. Oops. I want this to be white. 4x plus 6y is equal to 8. And 4x plus 5y is equal to 10. The way that this will work, again, I have two equations with two unknowns. When I look at the difference between these two equations, I can eliminate the x pretty easily. If, for instance, I multiplied one of these by a negative number, I'm going to multiply this the bottom equation by negative 1, and again why? So that I'll have a 4x on top and a negative 4x on bottom, because then those will cancel. So let's write this over here. I've got 4x plus 6y is equal to 8. And then on the bottom, I'll have negative 4x, because I'm multiplying by negative 1, minus 5y is equal to negative 10. And when I add these guys together, 4x and negative 4x, those cancel. 6y and minus 5y, well, 6 minus 5, well, that's just 1. So I only have y left over. And 8 to negative 10 adds up to negative 2. And there is my solution for y. So this is what y equals. So now I have to figure out what x and z are. Well, here I have 4x plus 6y is equal to 8. I could plug in negative 2 in for y, and I can get x. So let's do that. So I have 4x plus 6 times y, which I know is negative 2, is equal to 8. So let's start simplifying. 4x, 6 times negative 2 should be negative 12, is equal to 8. So 4x, I'll add 12 to both sides. Adding 12 will cancel that. Adding 12 to 8 will give me 20. Divide both sides by 4. X is equal to 5. Now we know what both x and y are because we eliminated z from our equations. So we'll have to go back to the very beginning. Let's look at this first equation here. I've got x plus 4y minus z is equal to negative 8. But I know what x is. I know what y is. The only thing left to figure out is z. So we have, I'll just write this again, x plus 4y minus z is equal to negative 8. But I know that x is 5. I know that that y is negative 2. I don't know what z is yet, so I'll just have to come back to that one. So 5, 4 times negative 2 is going to be negative 8, minus z is equal to negative 8. 5 minus negative 8 is negative 3. I can add 3 to both sides to get negative z. Negative 8 plus 3 is going to be negative 5. And z is equal to 5. Okay, so we did a lot of work and we came up with x, y, and z. So our solution should be 5, negative 2, 5. However, we did a lot of work and it would have been really easy to make a mistake somewhere. So let's check our solution. What I'll do is I'll come up, maybe this bottom equation right here, I will plug in my solution just to check. So 2x minus 3y plus 2z. So we have 2x minus 3y plus 2z is equal to 26. So let's check our solution. We'll take 2 times 5 minus 3 times negative 2 plus 2 times 5. If I simplify this, 2 times 5 is 10. Negative 3 times negative 2 should be positive 6. 2 times 5 is 10. And we get 26. And they match. So I've only checked one of the 3 equations. But I could go back through and check the other 2 as well. But I will stop here in this video, and we'll do another example in the next.